So today I'm going to be explaining the excitatory chlorogenic synaptic acetylcholine. So first we have an anion in the postsynaptic neuron. Then we have potassium inside the neuron. And then we have sodium outside the neuron. Then we're going to get a ligated receptor. And that goes on the dendrite of the postsynaptic neuron. And then from there, we're going to have acetylcholine gets released from the presynaptic neuron, and acetylcholine will bind to the ligated receptor on the postsynaptic neuron. So we have acetylcholine, and then it goes through the presynaptic, and it binds to the ligated receptors. When acetylcholine binds to ligated receptors, it causes the sodium channels to open because acetylcholine binds to receptors causes the protein receptor to change shape, allowing sodium to enter the cell. So then we're going to have sodium go through the channel, then into the cell. Sodium through the channel, into the cell, and another sodium. Through the channel and into the cell. When sodium goes into the cell, it causes the inside of the cell to become more positive than the outside of the cell, which that is caused by depolarization. If the sodium pump would allow potassium to leave the cell, it would cause repolarization. So then we have the Na sodium pump, which would go here, and then this pumps out the potassium. When potassium leaves the cell, it makes the cell more negative. So then it goes back to the rest potential. Then the sodium potassium pump comes in and pumps the sodium back out of the cell. And then the potassium back in the cell. So it goes back to the rest potential.